I don't have too many announcements today. I know for St. Louis, we are having a get-together, an in-person get-together on October 1st, which is a Sunday from 1 to 3:30. So you check that out. And we may be inviting people from the new in-person cohort to attend that as well. And in fact, we likely are. So if you want to stop by and study and also maybe give some advice or words of encouragement for people who are just starting the cohort, that is an opportunity to do that. Not a guarantee, but I'm pretty sure that we are going to be inviting people from this cohort too. We just don't want it to get too big uh, for the space. Yeah, other than that, I might not be as visible in Unit 2, but I will always be available through Slack, or if you want to schedule a meeting. So don't hesitate to do that. If you need anything, we do have a brand new cohort that is getting started. So a lot of my attention is going towards that and helping out with that. But yeah, like I said, please reach out to me via Slack if you have any concerns or questions or anything like that. And later this week, I'll be getting the dates up on the class schedule for liftoff. I still don't have the exact topics for each class, so that's why I've been holding off on doing that. But just having the dates listed out there would probably be nice for you. And that's it for me. Thank you, Carrie, and have a great class tonight, y'all.
Thanks, Colin. All right, let me get my screen shared back up here again. All right, I think we're good. Okay, so tonight we are talking about unit testing, which is not a topic that's new to you since you learned a little bit about it in Unit 1 with JavaScript when we looked at Jasmine, but tonight we are going to talk about how to do this with Java. So I'll do a couple announcements, we'll do lecture, and then you guys will do the Chapter 6 studio. So again, in case you missed it, we have a little bit of a schedule switcheroo. Everything should be updated now everywhere, but Class 9 is now on Monday the 25th. The catch-up class before the graded assignment 2 deadline is now on Thursday the 28th because I will be out that night. And then the graded assignment 2 deadline is on the 2nd of October. You get an extra few days there for that. And that assignment is going to cover topics from chapters 4 through 7. So we're not quite there yet. The things that we're talking about tonight are part of it. It's essentially going to cover object-oriented programming with creating objects from classes, and then unit testing, which we're talking about tonight. And it also is going to talk about include some aspects of inheritance, which we're talking about in the next class. But we're getting there. And to that end, I am creating an intro video to get you oriented to the instructions and a few things to watch out for. And that's mostly done. I should have it available later tonight for those of you who are eager to jump on it. Okay, so let's talk about unit testing. How to automate tests for Java. I will cover the principles of unit testing. It's a little bit of a revisitation of what we talked about in Unit 1, but just a refresher. Talk about JUnit 5 specifically, how to set that up in your project, what the annotations are for your test methods, the syntax for the methods, some of the common ways to make assertions, how to improve your assertions. This is something that is not in the book. I'm going to teach you an extra little trick. And then we'll talk about the import statements that are necessary to make those tests work. And then I'll talk a little bit about the differences between JUnit 4, which was used in the old textbook and is still used in graded assignment number 2, and JUnit 5, which is what your current project repository is using. And I also updated my lecture examples to JUnit 5 as well. And then, of course, I'll just show you quickly how to run the tests, which you may already know how to do with graded assignment 1. But we'll do all of that, and then I will do a whole lot of live coding of tests for you, and we'll take a break in the middle of all of that. But I'm going to give you lots of examples to work from. And I want to just say it now in case I forget to say it later. while it is important to understand why tests are important, and it's important to understand what the syntax is to write them so that they will run properly, the most important thing for you to take away from tonight's class is how to think through what you need to set up a test and to write a test to make it effective. Because your test, we're going to, focus on fairly simple tests, but I'm going to do a couple that are a little more involved just so you can kind of see my process for how I think through what test data do I need, how do I need to set it up, what order do I kind of do everything so that I know I'm testing my code effectively. So we'll take a look at all that. Like I said, I've got lots of good examples for you. All right, so the principles of unit testing. Tests are important because every code base is a living organism. You have new things that come along that require you to make changes to your code. And when that happens, if your code breaks because of a change in one place, but it breaks somewhere else, you may not be aware of it, and that would be bad. So automated tests that cover all of the different parts of your code will catch those kinds of errors that can sometimes come up when you make changes. And the tests themselves specify the expected behaviors and outcomes of your code. So they're actually a form of documentation. It's very useful for you and for other people going back and looking at the code. You can take a look at the tests and pretty quickly understand exactly what it's meant to do. The characteristics of good tests, they should be deterministic. This means they should produce the exact same result every time. I can't tell you how frustrating it is to write tests that are unstable, which can happen mostly when you have like race conditions, like you're working with an API and you're waiting for data to come back, and sometimes it takes longer than others, or a page takes, if you're doing like end-to-end testing and a page takes longer to load one time than another time, your test can be unstable. Unstable tests are not helpful. They need to be stable. They need to work every single time. The types of things we're going to be doing tonight, you're not going to have those kinds of elements introducing instability, so you're not going to have to worry about that for now. But it's just a good principle to understand. Stability is important. Relevant, that the test should be grouped together, by class and by the functionality, so that it makes sense that like things are with like things. The test should be meaningful. There's no point in testing trivial parts of the code like getters and setters unless you've done something to customize them that's worth testing. I said this a minute ago, it is important not just to know the syntax, but what should you be testing? How do you approach it? How do you set it all up? And you want to think through the positive cases and the negative cases. What happens when the code is working the way that it's supposed to? What happens if someone uses the code in an unexpected way, or if there's an error and you need to make sure your code is handling it properly? What about edge cases, just unusual things? And sometimes that can be as simple as just like, can my code handle an empty string if someone passes an empty string into this method, right? Those are all important. And then of course, the test data itself, what do I need to set up so that I have some good data to work with just to test the code? And can I make that reusable? We'll talk about ways to do that. All right, so that's kind of the big picture there. Let's talk about one more specific principle here that will help you think through how to set up your tests, which is the AAA pattern. So here's a good pattern. First, you arrange the variables your test requires. Get the data, set it up. Maybe you have some expected values you want to define so that you can use them in your assertions. Then you act on the method. You actually test your code, call your method from your code or whatever it is. That's where you're going to get back to the value that your code is producing, and you're going to compare it against what you expected to see. So the assertion, the third part, that's where you actually compare, okay, here's what I expected, and here's what my code is actually producing. Are those the same thing, or, are they different? Don't worry too much here in this example about the syntax. I'm going to break that up in a second for you. But do just pay attention to the sequence here, just these three things to think about. Do you have the data that you need? How are you arranging that? Are you acting on your actual code to make sure you're testing what you need to test? And then what are you asserting to make that comparison, to say, I expect these two things to be equal, or I expect this thing to be true, or this thing to be false. These are the essential kind of parts that make up a test. Okay, so if you're ready to set up JUnit for Java. Recently, when LaunchCode updated the curriculum, they updated instructions for JUnit 5 in the new curriculum. So it looks a little different than it did in the old one. And for a Gradle build, which is what you have in your Java WebDev projects repo that you're doing all of your chapter exercises and studios out of, you can look in the build.gradle file, and you should see these dependencies shown on the right, the test implementation stuff here. And if you don't see these, this is how you go about installing it if you're in a Gradle build. You would right-click to select Generate, and then select Add Dependency, and then search for this JUnit-Jupyter. This is the particular dependency you want to look for JUnit 5. And when you find it, you click on the little add down here to the right, and then it should update your dependencies in that build.gradle file. And you may or may not at that point need to actually rebuild the project immediately so that it's made available to your files. If you have a Maven build, it's very similar. It just looks different in the file, because the file is actually the pom.xml file, and so then it looks like what you see on the right with the XML instead. Otherwise, the steps are exactly the same. You use the same process to go through and get it added in. I had to go through my lecture examples and update everything from 4.13 to 5.10. And once I completed that whole process, it was just a matter of changing some syntax in a couple places, and I was good to go. All right, so that will make sure that you have it installed in your project so that it's available to use. So let's take a look at the file structure. The important thing is that the classes that run your program are in the main folder, and all the tests are in the test folder, and they should have a corresponding test class for any test you want to write for that class. And so you just name them by putting test on the end of the name. That's pretty much the convention. And different builds are going to have different file structures. On the left, you can see is a Gradle build that LaunchCode provides for your exercises for the chapter. On the right, you can see my Maven build produced a different file structure for my lecture examples. Either way, the important part is that structures are parallel, right? Everything in main has the same structure as in test, here and in here. So you can find, and I've got this, book and book test, library test, etc. So that's how you set it up. And with both Gradle and Maven, they automatically know about each other as if they were in the same package. So then there's these annotations that you're using. This is something when we, kind of get it more into the full fledged syntax in a second, this will all come together. But these annotations are used to designate your methods for their purpose. And so the most common one is test, because each of your tests is going to have a test annotation. But you also can use something like before each or after each if you have something you always want to run before any of the tests are run, before each test is run. And after each will run after every test. In JUnit 5, it's before each and after each. In JUnit 4, it's before and after. I'll go over that again in a second, because with things switching, you're likely in the real world, if you get into this, you're likely to run into both. You're going to, possibly use some of the older and some of the newer. So it's good to know about both. And I'll review that in a second. But these are called annotations. They just go right on top of the methods, and they let it know exactly what the purpose of that particular method is for, how it's meant to function. So let's look at the syntax of a method itself. And I know I'm just kind of running from slide to slide, guys, but honestly, I kind of just got to get through all the slides and get to the point where I show you how to run a test. And then we're actually going to go do a bunch of it. I promise. We will do some live coding and see how this works. So here again, let's go back to this example I had before of the, add returns correct sum test, right? So the signature of the test, you want to have a public void method, and you want to give it a meaningful name that's unique from all of the other tests. And it goes, right after that test, at test annotation. So that's how you set up a test. It's that simple. And Then the body of the test itself is where you start, putting all the code that's going to make that AAA pattern work, right? Arranging your data, acting on the code you want to test, and asserting the outcome. And that's what the assertion is actually what, makes the test pass or fail. And everything else is just, getting to the point where you can make that assertion. So that's just the body of a test. The syntax is fairly straightforward. I mean, it's just a public void method. You put the annotation on it, and then you make your assertion. So these assertion methods are something that are part of the testing suites. And these are some of the most common ones that you can do. Assert equals, just, you could say, here's what I expected, here's what I actually got. I expect these two things to be equal, and it's that straightforward. If you have doubles, which you remember are like long decimal numbers, you can, there actually is a third parameter delta you can use that will allow you to say it's acceptable for this to be accurate within, so many decimal points, because sometimes with rounding errors, you don't want a test to fail just because it rounded slightly differently than you expected it to. And that's what happens with computers. So that's a third parameter delta, but assert not equals works similarly. It just is the opposite. It says, I expect that these two are not going to be equal. Assert true, you just give it something that returns a Boolean true or false, and it will check and see if that is in fact true or not. And if so, the test passes, and if not, it fails. Assert false, of course, is the opposite. You expect it to be false, and if it's false, the test passes. And if it's true, the test fails. And then there's also assert not null. This is another great one. Just like maybe you just want to make sure that your data is real and it's not missing or empty. Assert not null is a good one to use just for doing that kind of a check. So those are some of the most common ones. There are lots more. You can look at the documentation for JUnit and look for all the assertion methods. There are many, many others out there, but you probably won't use much beyond these for the purposes of this class. Okay, so if you want to improve your assertions, there is one more parameter that is optional with these that I would like to introduce to you. I'm a big fan. So every assertion method has an optional parameter called message. And it always goes last with JUnit 5, but you can define a string that specifies what's being tested in greater detail. You can write a whole sentence to describe exactly what this test is doing. And this is a much better way to document your tests because it gives you an immediate way to look and see, oh, this is what this test is supposed to do. And it cuts you some slack on not having to make your method name carry the weight of that description, because you can actually just put it in a string instead and use more words. The other nice thing about it is that when you pass it into the assertion method as that last parameter, it helps you when the tests fail because it actually shows up as part of the test, error message. You can see down here, I've got this test failure and it says a new library has an empty list of books. That would not be there if I had not passed that in as this message up here as this third parameter after doing the expected and the actual. So that's something to keep in mind. I'm going to model this for you all night long tonight. And you can choose for yourself whether you decide, that you want to use it or not, but I highly recommend it. I think it's just much more thorough. It's not a big deal to add it in, and it just make your test better and easier to use. Okay, so I'm going to talk about the import statements needed for this, and then I'm going to go back and review that, what's different between JUnit 4 and JUnit 5. So the import statements, you basically have two different things that you have to import, generally speaking. And one is annotations. And sometimes you're going to end up with multiple import statements for this, like I've shown in the example, before each and test. Your methods, you can also get from a different place, and that's an import static statement. But you'll notice that I ended up just saying I might use a bunch of different assertions. Just let's cover all the bases. I'm going to use an asterisk to represent all of them. Go ahead and just pull them all in. And I think I said this earlier, if you're using Gradle or Maven, you don't need to explicitly import your classes that you're testing because they already know about each other, even though they're in separate packages, they're parallel. And because of that structure, they know about each other. And so it's no problem. If you're using this, installing this in something that doesn't have Gradle or Maven as a build, and you just kind of have a few Java files thrown in there with a config file, then you might need to import your classes, but you won't with most of the stuff you're working with for launch code. All right, so here's the difference between JUnit 4 and JUnit 5. For one thing, the dependencies are different. You'll notice that with JUnit 4, you're just going to see org.junit being the package. And for the assertions, it's org.junit.assert. But for JUnit 5, it's using this Jupyter API. So JUnit.jupyter.api for annotations. And then the assertions, it's actually, instead of assert, it's actually assertions. But otherwise, they work pretty similarly, but just be aware of that, because if you're working on your stuff for class tonight, you're probably going to see the JUnit 5 stuff. If you're working on graded assignment 2, you're going to see the older stuff because it still uses JUnit 4. So I just wanted to make sure to point that out. Similarly, if you decide to use some of these annotations that aren't just test, if you want to do like a before or an after, JUnit 4 had before class, after class. But they decided to update them in JUnit 5 to be a little bit more specific and easier to understand. So before each very clearly means run this block of code before each test, no matter, because the tests are randomized, just like with Jasmine in Unit 1. Tests are going to run in a random order. You don't know what order they're going to run in. So if you have examples, like you've created an instance of some class and you've got an object and you're operating and manipulating the values in that object in one test, you need to make sure that you're starting with a fresh object before you go do another test, because they may not run in the same order, each time. So these will do that for you. And before all is if you only want it to run once before all the tests run, after each and after all. So that's the difference between 4 and 5. The last thing is that the parameter order, I mentioned this optional message parameter that I like so much. Oddly enough, in JUnit 4, you actually put it first ahead of your expected and actual values, or like your Boolean condition in case of like assert true or assert false. But with JUnit 5, they moved it to the end, which makes more sense. So just be aware of that. If you are going to use these messages, where you put them is going to matter depending on whether you're using JUnit 4 or JUnit 5. Okay, so the last piece here is just to talk about how to run them. IntelliJ makes it very easy to run tests. You can run all of the tests at once, or you can run just a single test from anywhere in the file. And just like with your main methods and stuff, once you run it from the file, it'll be available in those run configurations up at the top right. And then you can run it from there too if you would like. Okay, and then the results will show up at the bottom. On the left side, you have the list of the tests, and it'll have a little green check by it if it passed and a little yellow exclamation point if it didn't. If there are any error messages, they will show up on the right. Once again, those details will only show up if you used that message parameter, that optional parameter. But it's helpful to immediately be able to know what test it's talking about without just having to look at the line number and go find it. If you have that message in there, that's what I like. One of the things I like about it. And then there also is a diff tool where you can click to see difference, and it opens up a diff where on the left you see the expected value and on the right you see the actual. And that can be really useful so that you immediately see, oh, this is what's not quite right about it, because it points it out for you. Like I did this example here where I did this book ID, and my test said, well, it's supposed to be, initials hyphen first 3 letters of the book title hyphen, ID number. But apparently the way I wrote my code, I have spaces in between everything, and that's why it's not quite right. So this, it's a very helpful tool. So I'm going to, I'm about to do a whole bunch of coding for you guys on all of this. I know this was a little bit of a whirlwind, but does anybody have any questions before I get into the coding? Mal?
I noticed on one of the slides on the better I don't remember the slide name, but anyway, you created variables for the expected and actual outcome. Should we be doing that instead of writing that directly into the test?
That is a great question. That question always gets asked, and you don't have to, but I'm glad you brought it up, because I do want to point out to you that I do it on purpose, just for the point of teaching it, so that when you look at these assertions, it's not just a bunch of information. You're like, wait, what do each of those things represent, right?
Right.
Because if you just look at the test and you've never done this before, it's obscured. Like, the purpose of each piece is obscured. So when I teach this, I very intentionally name them as variables: expected, actual, condition, so that you can see what represents what. And then when I put them in the assertions, you can see how it all fits together.
All right, that makes sense. Thank
Yeah.
you.
And then, when you get to the point where you're real comfortable with it, you don't have to do that anymore. You can just do it all in one line if you want. Wesley?
I actually had two questions. My first one's more in relation to like the why of testing.
Mhm.
I guess, like from my understanding, would it make sense that you want to create tests that you will never change? Like if you go and you change your code, your new code should always pass those tests to make sure that you're not bugging things, right?
Right.
Okay.
Yeah, unless you're actually are changing, the requirements, in which case you have to update the tests as well to make sure it's coming out the way it's supposed to now. But the intention is that you have consistent outcomes for all, any requirements that haven't changed, so that even if you make updates over here, if it accidentally breaks something, you're immediately aware of it.
Okay. My second one is I'm kind of having difficulty understanding where we're importing JUnit from. Like in those import statements at the top of our, um, I don't know, I think it might have, in one of mine, it's on line 3. Like, why does this need to be imported, I guess? And like, where is it within the,
Right.
within the,
So when you have it, and actually let me switch over to the code here for the POM file. So I've got a Maven build up right now for your chapter stuff and your studios. You've got a Gradle build, so it'll be in the build.gradle file. But you can see here that I've got dependency. As long as a dependency has been added to the project as a whole, then when it comes down to your individual test files, you just import what you need from those dependencies with these kinds of statements.
okay, that makes sense. Thank you.
Yeah. Gabe?
So my question's about the message field, and it's more about, I guess, so is the idea is that you write the message as if the test had passed or as if it had failed? Like that message, does it mean this is what happened?
The message describes the specification. It describes what's being tested. So in this example, I clicked on it. I should not have done that because this is not actually code. Okay. In this example, I've got a test that I've given the method name, the test method name, constructor sets book list, which is generally what I'm testing. But in this case, I actually decided to have two different assertions that will help meet this test. One, that the list of books exists in the first place. If I create a library, it has a list of books. So I decide I want to assert not null. So I give that message, a list of book exists. That's a good way to describe what it is that I'm testing. I'm making sure that a list of book exists. And then for the second piece, I'm making sure that a new library has an empty list of books. So it exists and it's empty. Those are the two things that I'm specifically testing to satisfy the entire test.
Okay, so I guess so if you see the message, basically that means that whatever is being said in that message is not true. Like that's
right.
what's
this is what's failing. So down here in the message, it says, assertion failed error. A new library has an empty list of books. Well, it expected 0 and it got 1 because I made it fail on purpose. I added a book and made it fail. Yeah, that's the idea, is it tells you immediately, okay, this is what we were hoping for, but it didn't work.
Got it. Okay, that makes
Yep.
sense. Thank you.
Yep. Yeah, and that's why messages are so great as documentation, because they literally specify this is what we're testing. This is how it's supposed to work. Okay, but there are no other questions. Let's go ahead and get into some tests. And we're gonna write one test for the utils method, the static method that's in our utils file. Remember, this is our librarian book project that we've been working on, right? So in the utils file, we had this little static method that just gets the initials. We give it a full name, it gets us the initials back. That's all we want. So we're just going to write a test that's going to make sure that that happens. And this will just be one, quick little test. And then we're going to jump over to book, and we'll have a whole list of tests that we're going to write to test different things about the book class. But let's do this one first. So this is the method that we're testing. The test says, write a test for get initials that will actually, sorry, I lost my place on my other screen. Give me a second. Woo, okay. Write a test for get initials that is just going to make sure it does what it's supposed to do. So this will be straightforward. So we need imports. So let's do that. For one thing, we're going to import org.junit.jupyter.api because I'm using JUnit 5. .test. I need that test annotation. Now I'm typing this in, but as you may guess, I don't have to. If I take that out and I come over here and I start writing my test and I say @test, look what happens. Because of the dependency already being installed, IntelliJ is aware that this is part of this dependency, and it's offering it to me. So I can just hit tab and then it just adds it for me at the top there. Now I can make this public void. Tests are always public void. And then I'm going to give it a meaningful name. So I'm just going to say initials returned from full name. And I'm going to designate a message, string message, and say get initials returns only initials when given a full name. This is what I expect this to do. This is what I'm testing. And then I'm gonna create a variable called expected. This is what I'm expecting the return value to be. And this is gonna be the actual. This is where I'm gonna test my code. That's what actual is. I'm gonna go to the utils class. This is a static method, so I call it directly from the class. I don't create an object. So I say utils.get initials, and I'm gonna pass in the string Grace Hopper. And give that full name because that's what get initials is expecting. And then what is returned from this call to my code is going to be that actual value that I want to compare against the expected value. So this is where the assertion comes in. This is where I assert and say, I'm going to assert that those two things are equals. And here again, I need to have it's not offering me the import, so I may have to type this one out. So let's come up here and import static, and then you just go to org.junit.jupyter.api. Good. And I'm going to say assertions, and then I'm just going to go ahead and use the asterisk because that covers all of the possible assertions I could need rather than having to have multiple ones on multiple lines. But now when I go to use this, assert equals, there it is. And I can just put in expected and actual. And we'll run this. Okay, so I can run this. I can run all the tests on the entire test class up here if I wanted to. If I had multiple tests, you can also run an individual test by running it right there next to the test. So I run this, it comes up below and it says it passed. So this is what it looks like when it's passed. It doesn't really tell you much. You can see on the left, initials returned from full name. That's the name of the method. Has the green check by it, no problem. Let's make it fail on purpose so you can see what that looks like. Let's say that instead of returning this, let's just return full name instead. We'll return the full name instead of returning what we're supposed to return, just to make this fail. Okay, so I'm gonna run it again. All right, and now we see it expected GH. It actually got Grace Hopper because the method itself actually returns the full name right now, right? If I click to see difference, I see GH on the left, Grace Hopper on the right. If you have something that produces a lot more code than this, this thing is especially useful. But yeah, when you're working on your studio tonight, you might find that comparison thing super helpful. It's, and it even tells me here, it's in utils test.java at line 17. It tells me where to go. But you'll notice I forgot to pass in that message, right? If I actually pass in the message and I run it again, it's going to fail again, but it also tells me get initials returns only initials when given a full name. This is much more useful to me having that message in there, because if I have a whole list of a dozen tests or more, being able to immediately know what it is I'm looking at. The expected and actual values are great. Having the line in the code I need to go to is great, but just mentally for me to immediately say, oh, I see what went wrong, having that message is super useful. So that's why I'm a big fan of adding that in. So you just do that in there as that third optional parameter there with JUnit 5, and you'll get that. And you'll notice that IntelliJ has put this little squiggly line under assert equals. This does not mean that your code is broken. It means, hey, this is where your test failed. It actually points it out to you, which is kind of nice. But then if I go and I fix my code and I return what was supposed to be returned. So now that my code should pass the test and come back and run it again, we'll see that the test will pass. There's no more error message. The red squiggly line has disappeared. Everything is as it should be. Okay, so that's that testing process. This is what it looks like when it fails, when it passes. That's a very straightforward test. And here again, I could have, instead of doing these 3 lines with these variables, I could have put those values directly into here, all in one line. It would be a little long, it'd be harder to read, and it kind of would obscure what is what. So for now, for the purposes of teaching you, I'm gonna make sure to always call these message, expected, actual. When we go to do like assert true and assert false, you'll see me use the variable condition to represent that Boolean condition that should be true or false. I'm just doing this just to make sure you're clear on what piece is which as I feed it into these assertions to make it very, very explicit. Okay, does anybody have any questions about this before I move to the next file? Nope, okay, no problem. All right, so we are going to go over to book test. First, we'll look at book. Let's just be a reminder here. We've got our ID and static ID, a title, author, num pages, available, which is a Boolean. The number of times something has been checked out is something new you haven't seen before, but is in this particular one. We can actually track how many times a book has been checked out. So we have these, getters and setters. We've got our custom toString, which actually checks some, has some alternate text depending on whether something is available for checkout or currently unavailable. The number of times it's been checked out will produce either a singular or plural, depending on whether it's 1 or a number greater than 1. So I've added I've added a little bit to this, right? I've made it a little fancier. And then we have our instance methods, generating that book ID, getting the title and author concatenated together, checking the book out, checking the book back in. And this pretty much looks the same as it did before, where we're changing available to true or false. But we also have this thing where we're actually increasing the number of times something has been checked out every time it gets checked out. So that's new. But that's it. That's our book class. This is the functionality we have with an individual book. Let's go write the test that will test all of the relevant pieces of code here for us. So we're going to come over to book test. We're going to add some of these imports that we need, and I'm going to save time because we have a lot of tests to write, and I'm going to just put them right there. So I'm going to make use of before each, and I'm also going to make use of test and then several different assertions. So we'll have those coming from those dependencies. Okay, so step number 1 is to sort out our test data. In order to test the functionality of this class, I need to create some objects of the class, right? This is object oriented. I'm going to create some book objects of the book class and have some different information in them. And we're going to use that as test data every time we run a new test. So the first thing I want to do is declare, but not initialize a couple of books. Just because I'm going to actually initialize them inside of before each block instead. So I'm just going to say, I want a book 1, I want a book called book 2. And then here, I'm going to create a method that's going to run before every single test, no matter what order the tests are written in. Yeah. And so I can just create a public void method that just says create test data. That's the purpose of this method, is just to set up our data for each test fresh. We have a new book object, new book 1. We'll do Hidden Figures by Margot Lee Shetterly. And it's got 271 pages. Missed a comma in there somewhere. All right, and then book 2 is going to be a new book. It's going to be Code Girls. Apparently I'm having trouble with my capital letters today. Okay. By Liza Mundy. And we're not going to give it this one any page numbers. That's okay. So again, what this means is that it will instantiate new objects, completely new objects, before every single test. And that's going to be important because, you know, I'm going to test some of the functionality, like checking a book out, checking it in, which means it's going to update the values of those. But if those tests run in, you know, one order or another, I need it to not matter. I need it to make sure it's stable, that every single time a test runs, no matter what order they run in, those we can count on those objects having the same data to begin with. And so they need to be fresh. Before each does that for me. So I'll do that, and that way my test data will always be fresh. Now I can just refer to these book 1 and book 2 anytime I want to use them. Okay, so now it's time to actually start writing the test. The first thing I want to do is to test my constructors. I want to test that my first constructor sets the title, the author, and the number of pages. So I'm going to write a test with the @test annotation and say public void, and I'll give it the name first constructor sets title. So it says what it does, but I'm also going to, you know, create a message that will represent it if I have an error message. Sets title. Some of these are going to be, you know, fairly simple. We'll get into some more detailed ones in a bit. So I'm going to say my expected value is that the title is going to be Hidden Figures. I can hard code that. What I'm interested in seeing is what actually comes back from my code. So I want to go to book1.getTitle. I'm going to call the getter for the title of book 1 and see that if I get what I expected to see, which is Hidden Figures, what I passed in to be the title. And if so, I know it's being set correctly, right? So here's the part where the test actually runs. We make an assertion. I'm going to use assert equals and say, take my expected value, compare it against my actual value, and include the message while you're at it. So let's run this. And it passed. Okay, so I can do the same thing essentially. It's going to be so similar for author. I'm just going to copy it and say author. And then here I can say Margot Lee Shetterly and say this time we're calling get author, calling the getter for the author field of the book to make sure that it is what we expect it to be. And I can run this one. And it passes. And then we'll do the same thing again with num pages. Now, the number of pages. Hidden figures is one where I did have the page number, and I expect it to be 271. And it's actually an int, so I need to change the types there. But otherwise, that should be good. Yep, and that one passes. Okay, so we've tested, these tested that the constructor is working as it's supposed to. That's a very simple thing. We also can test that our secondary constructor will assign a value of 0 to num pages if we don't specify the pages. And that's a different situation, right? So we have book 2 where we actually didn't give it any pages, and we're expecting over here that our overloaded constructor here that allows us to do that will actually just set it to 0 when we use it to call the original constructor and just pass in that value. So let's go back to the right file here. So I'm going to do this, and I'm just going to say second constructor sets num pages. Okay. Number of pages to 0 when not specified. And then we'll just say that we expect to see 0. Again, these need to be ints. When we get from book 2, this time we need to use book 2 as our test data because that's the one that we didn't provide any pages for. So let's give this a run. Okay, so hopefully you're starting to see kind of the process here. Each test has a very specific thing that it's testing. So we're specific in the way we name it, we're specific in the message we write. We say what we expect the value to be, then we go and we actually get the value from our code. And then we compare those two using that insertion method. And I am also passing in that optional message parameter as well. Okay, so we've got some, good start. We've kind of tested some things about our constructor. Now we want to check to make sure our IDs are being generated the way we expect them to. And this is especially important because we have some, we're not just assigning a number, we're assigning this concatenated thing of, different characters together, right? This generate book ID actually takes the initials from the utils. We call that utils method. We concatenate it together with the first 3 letters of the book title to uppercase. And then we go and get, that next ID number and then make sure that the ID number is increased for the static value held at the class level for the next book that's created to have a new number. So we want to make sure that all of that is coming out correctly. So we're going to come back over here and the thing that you have to think through. So this is where we start saying, okay, it's one thing to just say, okay, I'm just going to go and I'm going to call this method and get this value back. Sometimes you require a little bit of, a couple of extra steps. This one is where you have to think through about the way that the static value works with this next ID, right? If we want to know what we expect to see, we need to know what the next ID number is going to be before we set it, because it's going to get increased after that. So we can actually go and check that first and find out what that expected value is going to be before we create the book. And then that value will change. So let's write this. We're going to say, do our @test annotation, public void, and I'm just going to call this book ID generated. Keep that part simple. I'll create a message that says, a book ID is correctly generated using the static field next ID. And of course, there's much more to it than that, but that's sufficient for a message, I think. So here's this part where I was talking about where we need to get this expected value before we actually create a book. And we're not going to use book 1 or book 2. We're actually going to create our own test data just for this test. So sometimes you can, if you just need it in one place, just do it as part of the test, no problem. So I'm going to say, I'm going to take, if I know my book is going to be The Secret Life of Bletchley Park, then I'm going to start with, by Sinclair McKay, I'm going to have SM THE dash, and then I want to concatenate that with the class book. Remember, next ID is actually a static value that's stored at the class level. So I'm going to go directly to the book class to get this. What is the next ID number that you're going to assign to a book? What are you currently storing? And of course, I expect it's probably going to be 3, but it might not be. Just depends on how many tests have run before this and how many it's gone through. And because I don't know how many times books have been instantiated prior to this particular test running, I need to go and actually need to get what is it right now. So I'll get that from the class, and then I'll create the book and say book 3 is going to be a new book. I'm going to have The Secret Life of Bletchley Park by Sinclair McKay. And it's got 322 pages. And now I can go get my actual value. So I can say, I'm going to go to book 3 and I'm going to say, get book ID. What have you set the book ID to now that you have instantiated a book and, created that book ID? And if I compare now what I expected to see here against, what I actually get back, this is whether we'll know if the test is going to pass or fail. So I'm going to assert equals expected actual message. Yeah, add my message in there. Okay, let's run it. Okay, so let's say that over in my class, in my book class, that I actually, had not done this quite right. Let's say that I did do like I showed on my slide earlier where I had the spaces in here, right? If I go over and I run this now, I'd say, okay, I know what it's supposed to be like. Does my code actually meet the criteria for this? And it fails. I can see it expected it to be hyphens with no spaces around them, but instead I got, spaces and hyphens. Then I immediately have, that information to see what's different. I can go and I can fix my code. I've got the message there that tells me exactly what's going on. Oops, looks like I have a typo. But let me fix my code. I will put it back the way it was supposed to be. And then run it again. And it passes. Okay. But you can see that it was important for me to do this in this order where I actually went to the class to get what that next number was going to be. If I had tests that had run in enough different orders to where, other books had been created, that number might not have been 3. It's not something that I want to hard code because I don't know for sure. This is how you make your test stable, is to make sure that you're getting exactly the information that you need to get based on the data you're setting up at that moment, so that no matter what order the test run in, it will be correct. Okay, so we can do get title and author. We want to make sure that it's going to correctly concatenate the title and author together. That's a pretty straightforward one to do, right? So we'll do at test and set up public void title author concatenated. This has to be a unique name from the other tests and somewhat representative of what you're doing, but I'll use my message to actually make it more, explanatory. Get title and author correctly concatenates the title and author. I'll say my expected is going to be Code Girls by Liza Mundy. Okay. And that means that my actual is going to be book 2. Remember, that was the Code Girls example that we had. Get title and author. If we call, we're going to test this particular method of that class on, and it's a instance method. So we're calling it on the book itself so that it's specifically that information. And then we can just assert, assert equals on these the same way we have been with expected, actual, and message, since I have defined them all separately already. All right, let's run it. Okay, and it passes, so we're good. We want to test that the checkout method increases the number of times the book has been checked out. All right. So public void checking out book increases times checked out. You know, fun times with long method names. Okay. Times checked out is increased by 1 when book is checked out. So I'm able to be a little more specific there. I'm saying it's being increased by 1. So here's, okay, so this is a good example now of where we have to actually put some events in motion in order to get to the point where we can get the actual value we're looking for. And in order to check this, we have to actually check out the book, right? So we're going to take book 1 and we're going to call checkout, because that is where this takes place. When you check out a book, it increases time. It's supposed to increase times checkout by 1. So we'll check out the book, we act on it, and then we can say, okay, now that we've done that, we're going to expect that that number is going to be 1, but let's go check and see what it actually is. We'll go to book 1 and say get times, oops, get times checked out, and see if that value is in fact 1. And we can go ahead and, you know, compare those two. So let's, I forgot to put the test annotation on this, which is why it is not available for me to run. There we go. Yeah, if you ever don't have the green arrow next to this to be able to run it, make sure you put that annotation on there, because that's why it did not recognize it as a test. Okay, so we're good. So the last 2 here are, you know, is the is available. Is it true? Is it false? If you check it out, it should be false. If you check it in, it should be true. And this was a good one where we, instead of using assert equals, we can use assert true and assert false. Use some different assertion methods. So I'm going to create a test that is public void. We'll say checking out book makes it unavailable. And I'll just make my message available is set to false when book is checked out. That's pretty clear. We will check out the book. This is where we're acting on our code. And then we're gonna say our condition that we're gonna assert is false is going to be that book 1 is available. So that's, remember, is available is the getter for available. It's just named a little differently because it's a Boolean, right? So now we can assert false and say condition, and then of course the optional message parameter goes next for JUnit 5. All right, I ran the wrong one. Give me a second. There we go. Okay, yeah, and you even see my you know, my printout there. Hidden Figures has been checked out of the library. Okay, so we can use the same thing for checking it in, but we're going to just have one more little step that we're going to have to do. We have to check it out, and then we have to check it back in. All right, checking. Oh, book available after check in. Sure. I don't know why. Always does that. Okay. I'll create my little message available. It still doesn't say available. Is set to true when book is checked in. Okay. So first we'll take book 2, we'll check it out. Then we'll take book 2 and check it back in. So it was set to false. We already, you know, proven up here, you know, it does set it to false. Now we want to prove that it sets it back to true. We'll call our condition book 2 is available. And then we'll check it. We'll assert true this time. We are asserting that this condition is going to come back true. We're going to add a message. All right. there we go. It's been checked out. It's been checked back in, and it did come back true when we checked if it had been changed. Okay, so that's you know, a pretty good way to kind of run across different of your instance methods and kind of check that they're doing what they're supposed to be doing, checking your constructor to make sure it does what it's supposed to do. These are, you know, pretty standard, straightforward checks, but hopefully that gives you an idea of, you know, how to think through setting up, you know, how to use your test data to make sure that you are checking the actual versus the expected correctly. Because your test has to be set up correctly in order for you to be able to count on it testing your code the way you think it is. Does anybody have any questions? No? Okay, no problem. Let me jump forward a bit here. Since so we're going to take our 5-minute break. And when we come back, we're going to write some tests for the library class, and then we will be done. But I will see you in a few. Okay, welcome back. Well, let's get back to our code here. We have one more class that we need to write some tests for. We're going to test the library class. So you may remember here we have, let's see, get out to the top here. Yeah. So our library has an array list of books that is just an empty array list when it's first instantiated. And then later we have an instance method add book that allows us to, add books of, objects of the book class to that list. But we also have some other things here. We've got a special method to override toString so that we have a nice way to print out our entire collection of books. We have, the equals method. We've got a method called findBook that actually goes and looks to see if it can find the index of a specific book in the list. And it returns either the index or -1. And then we have a print available books that is going to, have a special way of printing just the books that have is available is true. So you may remember all those from before. We're going to write some tests to just test all of these things out. Somebody asked a good question and I answered it in Slack, but I want to answer it here too, in case you didn't see it. Are you expected to use true test-driven development when you're doing this? Right now, I'm writing the tests after the fact, right? I've already written the code. I'm just writing the test that's going to cover it and make sure that it's being tested in case it gets changed in the future. Perfectly fine. But if you do test-driven development, of course, if you remember this from Unit 1, the idea is that you write the test first, and then you write the code that satisfies the test as you're writing new code. That is something that for graded assignment 2, you're going to do a little bit of both. You're going to have some tests that you write for some existing stuff, and then you're going to have one task in particular where you're going to code a toString method for the job class that's going to let you add its functionality bit by bit over the course of 3 or 4 different tests. So, as far as employment goes, I have yet to work for an employer who really requires strict TDD. Generally, they're happy as you're developing, as long as when you, submit the code to be added into production, you just need to have good code coverage. Everything needs to be done and working. But I, do use it as part of the development process to make sure that I'm testing things I didn't think of. And I often improve my code in the process of writing the tests. So just as an aside, that's kind of how that works in the real world a lot of times. Okay, so now we're in a new file, and this is the library test file that goes with the library class. I'm gonna just quickly add these same imports up here in the top that we need. And then we're gonna do kind of like we did before, where we're gonna set up some test data using a before each block. So I'm going to just declare them first, book 1, book 2, and then I'm going to create a library called library. And now I'm going to create a before each method to set up this data so that it's fresh before each test. Public void create test data. And then I'll just say, book 1, and actually, this is going to be the same that I, did from before. I'll just copy it. Same 2 test books from before, and then I'll create a library and just get a fresh library that has, in theory, a empty array list with no books in it, no matter which test we're running. We'll always have a fresh library. Okay. So that'll run before each one. That's great. So let's start with the first test. We want to test that a newly instantiated library has an empty list of books before we do anything else. So this is one of the ones I actually had on my slides, but we'll code it bit by bit here. I'm just going to say constructor sets book list. That's a little bit misleading. The constructor itself doesn't set it as much as it does. It just creates it. I should just say the class creates the books list, I guess, but we'll roll with it. Okay. I'm going to do this in 2 parts. First, I'm going to check to make sure that it exists. And so I'm going to have a first message called not null message. And I'm going to say a list of books exists. That's my first thing that I'm testing, and I'm going to assert not null. And I'm just going to pass in library.books. Go make sure that library.books exists. And then I'll give it my message. And then the second thing is to say, I want to check the size and make sure that it does exist and it's empty. So I'm going to say, you know, size message is a new library has an empty list of books. And I'll say expected size is 0 and actual size is library.books.size. Remember that array list doesn't have length, it has size. All right, now I can do my assertion for this one, and I'm just going to use assert equals and give it the expected size, the actual size, and my message. I need my size message. There we go. All right, so because this test has 2 different assertions, I gave these very specific names so I could pass the right message into the right one. And that means if this test were to fail and one of these was perfectly fine, but the other one was not, it'll be really easy for me to tell immediately which one of them it was that it failed on. They're not going to fail. They're going to pass, but we're going to run it. Yeah, there we go. So it verifies that it does create that list, that books list exists, and it does have a size of 0 as expected. Okay, so now we can test add book, and we can kind of take that same approach. We can add a book, and then we can make sure that the size has increased and that the book exists in the list. We can kind of look at it from 2 different ways. So I'll write another test with the test annotation, public void, and say books added to library. Library, there we go. All right, I'm going to have a size message for this one. Book list has increased in size. And I'm going to say original size. Uh-oh. Okay, sorry. It's like it froze up on me for a second there. Okay. Original size is just going to be going to the library books and getting the size. So we know what size it is when we start. And then we can add a book. Add book, and we'll give it book 1. And then we can say that we expect the size now to be the original size plus 1. Whatever it was before, it's now going to be that plus another size. And then we can say the actual size is where we're going to go and check it again. Check the actual size with library.books.size. Okay, and now we can assert equals and say, let's check our expected size against our actual size with our size message. All right, so that's part A. Now let's do part B, and I've got something crazy going on here, so let me fix it. Okay, there we go. All right, so the second piece here is to just make sure that it actually contains the book object. So I'm going to just say string contains message equals book list contains book. That's pretty straightforward. And we'll just, I'm going to name this one condition because I'm going to use assert true. And I'm just going to say library.books.contains, which is just contains is just an array list method, right? And we can check for the actual object and see if it exists or not. And we'll assert true, that it does in fact exist. So I'm just going to give it condition and give it my contains message. And now I have 2 assertions in the same test that we can run. And we're good. Okay. We have this method find book. Remember that we'll just look and see if a book actually exists in the list. So we can, but it exists not based on the object itself, but based, like, does an object that has the same title and author exist. That's what we're looking for, just the title and author. So that's why it's different than just checking for contains. Okay, so let's write this one. We're going to test first that it returns the index. This is the positive case. Find book returns index. The book does exist, and we can actually get a positive index or 0 if it's the first thing in the list. So I'll create a little message to document this. Find book returns index of book that has been added. And then I'm going to add a book. This is where I'm going to act on my code. Say, take the library, add book 1 to it from my test data. And now we're going to say that we expect 0 to be the index that we find it at. But let's go use the code to actually look it up. This is where we test what we're wanting to test, the find books instance method. And I'm going to say, give it book1.getTitle, and then give it book1.getAuthor, because it expects a title and an author to be passed in. And now that I've gotten what the actual return is, I will assert equals expected actual message. All right. Okay, and it passes. So it did indeed find it by looking it up using the title and author. Okay, so what if we haven't added a book to the library and we want to go check and look for something with that title and author, and it doesn't find it? We want to make sure it returns -1. This is the negative case. So we're going to do something similar, but slightly different. So we're going to say book not found. We'll just call it that. String message equals find book returns -1 when book has not been added. Okay, so again, I'm going to take the library. I'm going to add book 1. Remember, we're starting fresh with each test. So I've got a fresh library, fresh book, because I put everything in that before each block. So I don't have to worry about anything that's happened in any other tests, and that makes this stable. But this time I'm going to say I'm expecting it to be -1, because I'm going to look for book 2 instead of book 1 this time. So int actual is going to be library find book, but I'm going to give it book2.getTitle and book2.getAuthor. We added book 1, but we did not add book 2. So this should return -1. And then, of course, our assert equals that, because I've set it up this way with these variable names, is the same. And we'll run this. And it passes. Okay. So we're down to our very last test, which is good timing because we're coming up on the end of the hour here, and I want to get you guys to studio. This one is when you want to test your equals method. This one's more involved. I wanted to make sure it includes something that was a little more involved in the setup because, again, thinking through how to use and manipulate your test data and line everything up before you run the actual test, the assertion, is important. Sometimes you have to go through a number of steps. This is going to be one of those times. We're going to do several things just to make sure that we're testing what we mean to test. So this one we're going to think through a little bit. So the idea here is we're going to test that our custom equal methods really does compare two libraries based on the titles and authors of the books that they contain. So we're going to need a library, our test library, but we're actually going to need a second library. And we're going to add books, extra books too. So there's a little extra setup to this one. So let's do the main, set up the actual body first. So I'm going to say library quality based on title and author. And then we'll set up a message that makes it very clear what we're testing. Custom equals method compares libraries based on titles and authors only, because that's what I decided I wanted to base it on, not based on the IDs of the books. So I'm going to start with, just saying, let's go ahead and add books 1 and 2 to our existing library from our test data that we already have. So we've got the first library ready for comparison. So that's the first part. But then we also need to have some additional books and another library. So I'm going to say book 1 copy. So this is going to be a new object that has the same information. And you know what, let me go and actually just copy this to make it go faster. All right, so book 1 copy, and then I can do that here, book 2 copy. Okay, so we have the exact same information, but they are unique objects. And same with our library, we're going to create a second library that is library copy. Oops, there we go. New library, okay. Man, can't type for anything tonight, apparently, guys. Okay, and then we just need to add our copies of our books to our library copy so that we have, man, getting ahead of myself. There we go. All right, so we'll do this with books 1 and 2. All right, so lots of setup just to get to the point where we can actually set our condition and do our assertion. But now we've created everything we need to do in order to check this. So I'm going to say Boolean condition is going to be, does library 1 equal library copy, just based on the fact that it has the same books with the exact same information. Because that's what this equal method does. It runs through, let me find it. I gotta find it first. Yeah, here we go. It goes through and looks at each book and just makes sure that it finds the exact same books after making sure that they are the same size, that there's not additional books in there that it's not looking at or whatever. So we're just testing to make sure that this works. And so now that we have that condition set, we can test it. I'm going to assert true condition. I'm going to give it my optional message parameter and we'll run it. From here, there we go. Okay, and it passed. Now, if we wanted to do the opposite, let me break this on purpose. Let me give it, give one of these a slightly different name that doesn't match quite right, and run it again. Yeah, so, we definitely get, we get the message, we get all of this. But of course, you want to make sure that your test data does work for what you are asserting. And of course, I do want this to come out true. So I want to make sure it's right. But I just, sometimes you can do that just to test it the opposite way just for a second. But there's no reason really for me to run it the opposite way necessarily. But you could if you wanted to. You could run it both directions if you wanted to have a positive and a negative case. But that's all we have time for. So who has questions about anything that I've done since we came back from the break? I know I've given you guys a lot of examples. Any last questions? No? That's okay. All right. Okay, so we are going to be talking about inheritance on Thursday, which will kind of bring everything full circle on object-oriented programming with the classes. And then on the class after that, we'll talk about interfaces and polymorphism, which is related to that. But then after that, you are going to actually have a total switch, sort of, kind of, where we're going to jump into the Spring framework for the first time and look what it's like to actually use a total framework to put together a Java project and work with, routing for like a web page. So we're actually going to get back to the point where we're using all of this knowledge that you've been doing to work towards building web pages. So we're working towards that. It's coming along. We're doing good. Let's talk about tonight's studio, chapter 6. This is a studio called Balanced Brackets. So you're going to look in your project repo for the unit testing studio directory. And then you're going to come up with 12 tests. You get to decide what they are to find errors that are in the existing code in a class called Balanced Brackets. And then, of course, you'll want to code your tests in the corresponding file called Balanced Brackets test that is in the parallel structure in the test folder. I will say this. The code that they've written for you already works for most of the all of the positive cases, I think, just about. So you may find the test pass perfectly fine for a while. So you're going to be writing a bunch of positive test cases. When you start testing different negative scenarios, that's when you find your code may not always work. And that's where you're going to use your tests as a way to help you sort out what needs to be fixed about your code. And you can make those changes as you go. Think about edge cases, like what if somebody passed in something that didn't have any brackets at all? What if somebody passed in an empty string? These kinds of things. And you should be able to come up with 12 tests. I do have the review for this already up on YouTube. It will publish at 8:30 Central Time. So you guys will have access to that after class. Yeah, this is a good one. And it's a good one to work together if you guys want to, pair program on something like this and kind of come up with the test together and think it through. That's going to be really useful. All right, so I will let you guys get off to it, and I will see you on Thursday for inheritance.